Okay, so this is the essay part of the component 3 upper 6 mock for paper 2, and I'm just going to plan it really. I'm not going to write it. You can write it, you can look all the stuff up in your book now. So following to medullary thickness of different mammals and their native habitat. So what's this about? Medulla, kidney. So I've got a beaver, which is aquatic and has a short, so this is increasing length, isn't it? Going from 1 to 7.8. So this is a short medulla. What do I know about the medulla? It's got the loop of Henle in it. I've got a human, I've got an arid environment with a kangaroo rat, which I know has got the longest loop of Henle. So, tells me the medulla thickness relates to the length of the loop of Henle, and we've got a different strategy in reptiles, birds and insects. What do I know about those? I know that they are doing uric acid, and that this relates to water reabsorption. Using your knowledge of the normal functioning of the kidney and the types of nitrogenous waste, and then I've got my table. That's brilliant. That clear scaffolding to the 3 areas. So using your knowledge, so these are my clouds. 1, 2, 3. So I've got normal functioning, I've got loop of Henle length, which is what the data table's about, and then I've got other nitrogen waste. So in normal functioning, we're talking about conserving water. I can't imagine not just going through this whole kit and caboodle, but I need to really concentrate my answer on proximal, but obviously you've got the same water being conserved there. The length of the loop of Henle, I need to talk about salt concentration of the medulla, and then collecting duct, I'm talking about water reabsorption. And of course I will need to therefore talk about ADH, I think. So salt concentration, so I need to talk about the different permeabilities, I think, here. So I think that's okay. So I can do ultra, selective, reabsorption, sentence on each of those. Then I'm going to do the descending limb, water out, the ascending, active transport of sodium ions out. I'm going to talk about the concentration gradient, water potential in medulla, and I'm going to talk about the collecting duct, and I'm going to then mention ADH, and that's all beautifully logical order. So length of loop, I've got arid environments, long loop, big salt concentration gradient, more water reabsorbed, and the opposite for short and something in the middle. And I've been given all this data, so I might as well refer to it. Mind myself, refer to data. Good idea. And also I need to talk about the environment. So I need to talk about whether it's aquatic or anything else. So types of nitrogenous waste. I want to talk about, what have they said? different strategies. So we're talking reptiles, birds, insects. They've got uric acid. So we talk about conserving water. I don't need to talk about ammonia because that's fish, and if they run out of water, actually getting rid of ammonia is the least of their issues. So low solubility. I want to talk about water. I want to relate that to water, and I'm also going to talk about light for flight. So I might add in short there as well. So in between this, I'm to refer to the data, the environment. Job's good and I'm ready to start writing. So what, 5 minutes to plan, maybe 15 to write, 5 minutes per paragraph. It might take slightly less if you do a good plan.